back to yet another DSA video. So I recently solved this question on Leetcode, count number of nice subarrays, and this is a really good sliding window plus 2 pointers problem. So without wasting much time, let's get into the video. So I saw this question on Leetcode. The number is 1248 and the name is count number of nice subarrays. So the question here says that given an array of integers nums and an integer k, a continuous subarray is called nice if there are k odd numbers on it. Return the number of nice subarrays. So what the question demands here is that if we are given an integer called nums and there's one more integer called k, so we have to find out the number of nice subarrays. Now what are the nice subarray? A nice subarray is one which has k number of odd numbers on it. Okay, and we have to return the number of such nice subarrays in the question array that will be given. So looking at the first example here is 1 1 2 1 1 and k is given as 3. So let's try run this example. 1 1 2 1 1 and the k is equal to 3. So we have to find out the number of subarrays in this question, in this array, which have k odd numbers. So k odd numbers is in which has 3 odd numbers. So for example, this is one subarray which has k number of odd numbers, and this is one subarray which has k number of odd numbers. Sorry for that. Yeah, so we only have two nice subarrays which has k number of odd numbers. Okay, and then if you look at this 2 4 6 and k is 1. Now since this has all the even elements, there is no odd number and the answer is 0. And then if you look at this example, it's a pretty big one and it has 16 such subarrays where there are 2 odd numbers. Okay, now let us consider a few more examples, somewhat bigger examples. Okay, so if you look carefully, I'll give one example. 2 2 1 1 2 1. Okay, so suppose we are given this array and let's say our k is equal to 3. Okay, now what is the first approach that comes to your mind? What is the first thing that you'll do? You'll try to find all the subarrays within this array, correct? So you'll find 2, you'll find 2 2, and then you'll find 2 2 1, and then you'll find 2 2 1 1, 2 2 1 2, and etc. The list goes on, right? And then within each subarray, you will check if there are k odd numbers in it. If there are k odd numbers, it will be a nice subarray. Okay, and you'll increment the count of the nice subarray. Okay, that way you'll get the answer for sure. This is going to happen. But imagine the number of times you'll be going through this array. So that is going to take a lot of time, right? And as developers, we are always expected to write a better code, a code with lesser time complexity, correct? So in this particular question, if we look carefully, we will be traversing sequentially, correct? Can we use 2 pointers for this? Can we use sliding window? Sliding window is basically used for problems where a particular window consists of the conditions that we want to be met by that particular window, and based on our requirements, we increment or decrement the size of that window. So this question can also be solved using sliding window and 2 pointer approach. Okay, now how we'll do that? So if we look at it for this particular array, I'll just write it here or to dry run, and then if we look at it, we need to find out subarrays with 3 odd numbers, right? So we have this one here. Okay, this entire subarray has 3 odd numbers, that is 1 1 1. This subarray has 3 odd numbers, that is 1 1 1. This subarray also has 3 odd numbers, correct? 1 1 1. Now if you add, for example, if you add one more 2 to this, can you now guess the number of subarrays? It will be this, that is, let's just write it down, 1 plus this 1 plus this 1. Now if you're considering this 2, will this entire subarray will also be a nice subarray? So that is plus 1. This entire thing will also be a nice subarray, plus 1. This is also a nice subarray, plus 1. So the answer here is 6. That in total we have 6 nice subarrays within the given array. Okay. Now, if you notice, before adding this 2, this were our options for the answer. Okay. This, then this, then this. So before this 2, we had 3 subarrays which were nice subarrays, and after adding this 2, we got 3 more, and those 3 were the same subarrays. Just this 2 was being added to all those 3 subarrays that we had earlier, and that resulted in total of 6 subarrays. Now, if for example we had a 1 here, okay, so now until this point we have our k as 3, that is the count of our odd numbers is 3, and for this subarray we have k is equal to 3, correct? Now what are the additional subarrays? As we already found out, this, and then these, this, and this. This was 6, but can this be a valid nice subarray? No, because here the number of odd elements are greater than k, and we have a constraint of strictly equal to k. But this is a valid subarray, right? So this adds on to our number of nice subarrays, and the answer for this array will be 7. It will have 7 nice subarrays. Now what are we doing here? So for example, let's take a few variables, okay, to track the count of these things. So let's take count variable. Now what will a count variable do? This will count the number of odd elements that we have in the window that we are looking at currently. Okay. Then let's take a starts variable, or let's call it number of starting points. Okay. Now what does number of starting points mean? This is basically the starting points of a valid subarray. Okay. Now I'll be explaining more about this while we get into the explanation. But let's just think of it as the number of starting points that we will have for a particular window which has k odd elements. Okay. Now how do we start a sliding window or a 2-pointer approach? We take an L, we set it to 0. We take an R, we set it to 0. Correct? So here also our L and R will start at this element, at the 0th element. Correct? And then after this we will say, okay, let's go to 2 and let's find out, do we have an odd element? No, we don't have an odd element. So that will just means, okay, our count remains 0, correct? Because we do not have an odd element at this point. So this will be 0. Then let's move our R to the next element at next to. And this is also not an odd element, this is an even element. So the count still remains 0. Let's move R to the next element. Okay. So this is now a 1. Okay. So for a 1, this is an odd element. It will satisfy our condition. Correct. So we'll increment the count to 1. And at this point, we will just check, is count equal to k? No, count is still less than k. So that means we have not found a window which contains k odd elements. Correct? So we'll just move R. So R comes here. Now is this an odd element? Yes. We'll increment the count to 2. Now we'll move, again we'll check, is count lesser than k? Is count equal to k? No, count is still less. So we again move R. We go to 2. Is this an odd element? No. We move R. We go to 1. Now is this an odd element? Yes. We increment the count. Now is count equal to k? Is count equal to k? Oh, sorry. The answer to this is yes. Now, here comes the catch. Whenever the count equals the k, so you know that this point, the R point, is the end of that window where you have found all the k odd elements. Okay? But the L is at this point. Is this the only subarray which is nice? No. We have this as the nice subarray. We have this as the nice subarray. And we also have this as the nice subarray. Here comes the main logic. What we'll do, whenever the count is equal to k, we will say, you know what? Increment number of starting points. Okay? Just increment them because we have found a starting point. Okay? So this L is a starting point. So we'll just say, we had since initially set it to 0, both to 0. We'll now say, okay, whenever the count is equal to k, we'll incrementing it. Now, we'll check, is this first element where our L is standing, this first element, is this an odd element? Because, I'll tell you why. If this was an odd element, then in that case, whenever we shift our L to the next position, that is this 2, the second position, we will have to remove this odd element from our count because we ran into this condition only when the count was equal to k. And if our L is standing at an element which is odd, then on moving L, we know that this is no longer a part of the window that we are looking at and the count is no longer k. Correct? So had this been 1, we would have reduced the count and we would have come out of the loop. Okay? But since this is 2, we'll say no, increase the number of starting point and move L to the next element. Okay? And since on the next element as well, this is also an even number, again increment the count, move L to the next element. Again we moved L to the next element. Now this is where L is standing and this is an odd number. Correct? We will increment the starting point to 3, and as soon as we get to know that L is standing at an odd integer, what we'll do? We will decrement the count value. Okay, we'll decrement the count value and we'll say, you know what, move L to the next position because our work here is done. And at this point, when L is standing here and R is standing here, we know that the count is not equal to K. We will come out of the loop and we will say that, let's just add one more variable here called answer. Let's say result. Since we have already taken the count variable, let's call it result. Okay, result will be the total number of nice subarrays. So as we come out of the loop and we know here that the count is not equal to K, what will we do? We'll just say answer is equal to answer plus number of starting points. Now what did I do here? I counted the number of starting points for a window that ends here. So these 3 are the starting points for a window that ends at this 1. And now when my L is at this point, I don't have enough number of odd numbers to call it a nice subarray. So I don't have K odd numbers. So I will have to move my R to the next element. And here we are adding number of starting points to our answer variable. That is, we have these 3 subarrays for this particular window. Okay, now we'll move R since the count is not equal to K. So the R comes here, and here comes the catch for this code. Very important catch. Now it's a 2, correct? We're not doing anything. Now, whenever you come down to this statement, the number of starting points is still 3. So for this 2, for a window ending in this 2, the number of starting points are still 3. This, and this. And this 2 will also contribute to all the 3 subarrays that we just calculated. And that will give us our answer as 3 plus 3, which is equal to 6. So until this point, we have 6 nice subarrays. Now, since this one was a 2, it was not an odd element. So we increase our R. We make it go to 7. It comes here. Now this is an odd element. Okay. And our L is standing at this position. And this is an odd element. We increment the count of increment the count variable, calling it 3. Okay. Now, since this count has increased and we have found an odd element here, we are going to update our number of starting points to 0. We are going to reset it to 0. Why? Because had we used these starting points for a window until here, this is not a nice array because we have 4 odd ones here. For any array starting from subarray starting from these 3 points will end up in K plus 1, that is 4 odd numbers, right? And because our L was standing here, we need to find new number of starting points. Okay, which is why whenever we encounter a new odd number, we have moved our window ahead and we reset our number of starting points to 0. So it's no longer 3. And now when you have encountered a number, an odd number, and you have incremented the count, again the count is equal to K. What are we going to do? We'll increment our number of starting points. We'll call it 1. L is standing here. We will see is L an odd number? Is the number standing at L an odd integer? Yes, it is. We'll decrement the count and we'll say move L to the next one. So move L to this one. Now since the count is again not equal to 2, we have only one starting point and we come out of the loop because count is no longer equal to k. So here it is. Answer was 6 plus number of starting points, which is 1, gives us an answer 7. And we'll exit our loop as soon as r goes out of the size of the array. So here when r is equal to 8, we have no element to access. So it goes out of the loop and we have a final answer as 7. So there are total 7 subarrays, 7 nice subarrays within this array. Coming to the time complexity and the space complexity of this approach. The time complexity here is obviously going to be big of n because we have only iterated through the entire array once. So we are only going through, like at most we'll go through one element wise, but it's going to be big of n. And the space complexity will be big of 1 since we are not using any additional space other than these constant pointers. Okay, and also this is, let's just call it answer only, it can be a bit confusing. Yeah, so this is all for the time complexity and the space complexity. Now let's look into the code. Let's start the coding. Okay, let's just start with initializing the variables. I'll first start with int n is equal to nums dot size to store the size of the nums array, and then we'll say int l is 0, r is 0, count is 0, and int l is 0, r is 0, count is 0, and number of starts is 0. Also answer is equal to 0. Okay, so we have initialized everything to 0. Now we'll say while we are going to run the loop for sliding window while r is less than n, that is our moving pointer should be less than the size of the array. While this is happening, if nums of r mod 2 is equal to 1, that is, now this is the condition for the odd, for an element or for a number being odd. Okay, the modulus by 2 should be 1. So if it is an odd number, then we'll just increment the count and then we'll say, increment the number of starts. Okay, sorry, reset the number of starts. And then once this is done, if we run across a condition where the count becomes equal to the k, then we'll say number of starts, increment the number of starts, and if we come across if the number which is standing at L is an odd number, so what do we do in that case? We will just say decrement the counter and we will increment the L pointer. L pointer will be incrementing in the entire while. Now here we'll be finding our number starting points. So what will say, add the number of starting points to my answer and increment my r. Okay, now when this entire loop is done, we'll just return the answers. Now I've run a few test cases here for reference. We'll just check if this is working fine. Okay, so I made a mistake in, there was a typo error. And it runs fine. So this is the final, like the final test or the final example that I use for dry run. And let's just try to submit it. And it got accepted. So yeah, that was it for the problem count number of nice subarrays. Let me know if you guys liked it and if you want any more DSA or Leetcode problem videos. So yeah, that was all for the video. Thank you and bye bye.